Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it later on demand. Following today's webinar, we will be sending out an email that contains a link to access that webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions. And we'll take as many as we can in about the last 10 minutes or so of today's webinar. And finally today, at the end of today's webinar, we are going to be doing a drawing for 3 $50 Amazon gift cards. So stick around and hopefully you will be one of our lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is how to secure containerized applications. Our speaker today is Doug Coburn, who is Director of Professional Services at Signal Sciences. Doug, thanks for joining me today.
Thanks for having me. Excited to be here. So thanks everybody for joining, and hopefully you'll find this valuable and learn something and find it as interesting as I do. This is a topic I'm quite passionate about. Just kind of a little bit about my background is I come from quite a varied background. I started in endpoint management. I moved to a functions as a services company called Iron.io before ended up here at Signal Sciences at the web application firewall layer. So seeing that kind of transition from monolithic applications to containerized application is something I've found fascinating over the years. So I want to go ahead and talk about how did we get here? And I find this to be very important because we do have a lot of new applications out there. We have a lot of people who are designing cloud native applications from the ground up, but we also have a lot of organizations that are trying to transition their current applications into the new kind of container world and DevOps type approach. So some of that history or background was we started with more of a server traditional centric model, very monolithic applications, these very large applications that did many types of tasks, all self-contained, and usually in a waterfall type development cycle. This meant that updates were quite long in between. It could have been monthly, quarterly, half yearly, yearly, in between kind of major updates. This did mean that you had a lot of control over how the operating system was configured, how the applications were configured and secured, and it was a little bit easier to implement security controls across that landscape. We then moved to more of a VM-centric model with the n-tiered type model, and we started to separate systems where these systems now, instead of necessarily being all contained in one location, we're starting to be broken out into different virtual machines. And definitely you can see that trend moving towards the containerized model. So what we see there now is today's world, and it's quite an exciting world. I find it a lot of fun. And we have containers. Containers have been around for a while. Actually, there was a container since the early 2000s. It wasn't really until Docker kind of took off, and for a little bit we had Rocket there and kind of took over that market and just made it easy to deploy these containers and start moving towards this microservices approach that they came into its power. And now we see a lot more of a DevOps, and the new word that I see a lot is DevSecOps, and kind of an agile approach where we've moved from the monolithic monthly, quarterly, half yearly, yearly type updates. So now we're looking at potentially daily or even hourly updates as we release new functionality and do this kind of iterative development that is the new model for today. One of the things that I found very interesting is I've been doing research on this topic is that, and one of the things I've seen as part of my experience, especially at the Iron.io days, is with the shift to containers, people who have existing monolithic applications, they have to do things in phases to actually get to a point of deconstructing the functions and tasks within that application into a containerized approach. So one of the things I've seen with a lot of customers is the very first step they do is they potentially just take that whole Tomcat server or Apache server or Nginx server and drop it into a container. No real changes. It's the exact same as it was on that VM or physical server. So it's quite beefy and somewhat unwieldy. I've seen some of those build processes for those containers take 2 or 3 hours to actually finish building and running. Doesn't quite give you the real value add of what containers can bring to the world, but it often is a first step. And this also means any vulnerabilities or issues with that application are still inherently there. And then as people mature in kind of their container approach and start kind of making baby steps forward, they start pulling out particular functions from that monolithic application. So a simple example that I always like to use is maybe something around PDF. So the first function you might pull out would be generate PDF. And then as you go through, maybe another function you pull out is email PDF. And eventually you get to a point where you have the ecosystem of microservices communicating to each other. And now you have a lot more lightweight containers that are easy to update and deploy, and some of the values that we'll be talking about. But one of the things that this does introduce is generally you're going to need a communication layer. They're not natively part of the monolithic application anymore. So this means that they need to communicate with each other. One of the most common ways that they communicate is some type of HTTP. REST is one of the most often I see. I've seen some SOAP as communication. Then I've also seen HTTP2, and then over HTTP2 using gRPC, or in some cases, gRPC directly. So why is this important? So this complexity is a completely new model of security challenges. We've moved away from some of the traditional approaches where you're just securing an operating system, maybe like a VM host configuration, and you have a set of controls that are quite standard either for VMs or servers, to now a whole new set of security practices that you have to think about. You have to think about how is the container itself configured, which is effectively the OS. How is the host for the Docker that's running the container configured? If this is part of Kubernetes, are the APIs locked down? Do you have role-based access control configured? And that whole kind of model has changed. And other things are, if you do move from a monolithic application to a kind of containerized and DevOps approach, you now also have to think about how do you authenticate to that function? As it was built into an application originally, this might not have been an issue because it was all part of a previous part that did the authentication. Who's allowed to use it? What data is it supposed to return? So that's limited to really just the particular task that it's working on. So there's a lot of new considerations that you have to think about when you move to the containerized and DevOps world. Of course, there's always benefits. So one of them is that you can update one part of that function as opposed to having to update the whole application. This is part of the reason why you can have a lot of quick, short deployment cycles, because you're not having to update everything just to update one particular type of function. It also means that the applications generally become more fail-safe, so that if you do have something in one portion breaks, the whole application, which is usually comprised of these microservices, often will still be able to run and potentially self-heal and not actually come down. So your reliability and uptime definitely can improve. It's also easier to maintain those functions and be able to just focus on a particular task. And when that function or microservice is doing one thing and it's doing one thing really well, it's a lot easier to be able to focus on that as opposed to having it part of a larger kind of structure. And then also for new app owners, as they're coming in and learning different types of things, I know for me personally, when I'm looking at code, it's a lot easier to look at a function that does one particular task as opposed to looking at thousands of lines of code that does everything all in one. So I found this interesting article as I was doing research from techbeacon.com. And one of the things that stuck out to me, and this is kind of the core of what I wanted to talk about, is for me, the application, often when I've been doing research, doesn't have as big of a priority as the overall container security in the environment that it's running in. But and I liked this particular line, is the other way that you can expose this is you have an internal API that accidentally gets exposed externally. We never want this to happen, and usually it shouldn't, but as we all know in real life, mistakes happen. So now you potentially have an internal API that was never supposed to be externally available suddenly become externally available. And as this article mentioned, Shodan and other tools out there means as soon as it becomes externally available, it's very likely to very quickly be detected and potentially becomes a risk and a compromise to your whole environment. So that brings me to that kind of next topic is a compromised web app can mean that a compromised Kubernetes cluster. So we have seen this. I included a couple examples of articles that talked about where a compromised web application has been that front door to actually compromising Kubernetes. Also, as I was doing research, I found it very interesting that a lot of the products out there, the kind of layer 7 protection for the web applications and security and containers is almost an afterthought. You see a lot of information about is your Kubernetes RBAC controls in place? Is the permissions for the container so that it's not running as a privileged user? Is that configured correctly? Have you checked the source third-party image that you might be referencing? So a lot of things about that environment, but not a lot of focus on actually that layer 7 vulnerability, which arguably is often the biggest kind of front door into your Kubernetes environment. So why this is important is if we take a look at an example pipeline from like a CICD approach, in this case, the model that I've set up here is actually going to be using Circle CI, but I have a simple GitHub repo that is for a SCIM server that I set up for doing provisioning for our product. And it's pretty straightforward. I push updates to there. I have a configuration file for Circle CI, which is pretty straightforward. It's nothing too complex or out of the ordinary. But what it does is it actually goes through, sets up an environment, builds out some unit tests. If those are all successful, it actually builds a new Docker container, pushes it to Docker, and then actually pushes it out to my Kubernetes environment. So we see here that this is actually executing. So when I'm checking in the code, it's actually distributing this out to the Kubernetes environment automatically. Obviously, if I was doing this in real life, this would probably be a dev environment where that last step of pushing to Kubernetes would just happen in an automated fashion. Production, you might want some more checks and balances in place, but it's very easy to very quickly deploy things out into the wild, so to speak. So we can see here that process kicked off and had a new container. And finally, I have a deployment here where it's actually been deployed in the environment with that actual container, all with me just doing a check-in to GitHub. So again, and this is something that I say when I talk to a lot of my customers, is the app is part of the container. It's not a afterthought, or it's not a separate security model you need to think about, but it needs to actually be part of your container strategy. So one of the things that I've heard a lot of people talk about is security in layers. It's always going to be multiple layers to get the most secure kind of approach that you can. So one of the layers is, let's look at the environment that the container is running. Another layer is, let's make sure that the application is protected at the layer 7. Let's also make sure that the Kubernetes overall environment is protected. So there's multiple layers that you need to think about when you're thinking about your container security strategy. And definitely, because it is the front door, the app is a huge part of that. So speed is quite scary from a security perspective. The faster you deploy means the easier it is to potentially release something that can be vulnerable. And visibility is a very important part of this, being able to see what's actually happening, being able to see, are you actually getting scans? What are they scanning? How are they scanning? Not just have they done attacks, but kind of how they're profiling your environment, and then actually doing those attacks and are they targeted? Are they just generic? What that might be. But the whole CICD model gives you that quick development cycle, but also means quickly releasing something that maybe somebody forgot to write a unit test, or maybe there was a tool that was supposed to be scanning, like an IAST or DAST tool, that missed something and now it's in production. So another part of that is having the ethos from a development and tools practice that you have a very strong security-minded focus when you're doing your development life cycle, so that the people actually writing the code are thinking about this, that you have the tools in place before you ever deploy the code, that you have strong unit tests that are actually testing to make sure various types of things are actually working as expected before you ever actually deploy it. And then when you do deploy it and it's in the wild, that you have layers of protection for that actual application. And then what I like to call my silly mistake, and I have an example that I'll be showing after this, where if you do make a silly mistake, and often I've seen this actually do happen in the wild, where it's a newer developer, might not be aware of some of these security implementations, and that can go out very quickly. This kind of brings us to the containers, which make it very easy to move through environments. As you can set up at one container, you can test it in dev. If everything looks like it's good to go, you don't necessarily need to rebuild everything for your QA or prod. It's usually just a matter of setting different environment variables for that container that determine, oh, this is dev and this is production, even though it's the exact same container. So moving from one environment to the other becomes simplified when you're actually doing that deployment. Also, just from a security mind, as kind of mentioned, there's often a reliance on third-party images. So we use a lot of the ones out there. Most of the customers I work with don't go and create their own Debian or their own Alpine, so they're being provided. So making sure that you're using it from trusted registry sources, that they have the correct checksums, and it is actually the image you expect is important. I've also worked with a lot of customers that will actually create their own and make sure that it's certified, that it actually meets the security standards that they need to. And of course, containers make it very easy to build and very easy to push. Once you embrace that kind of microservices model, it can greatly reduce the build time for things, especially as you use tools like Circle CI to have a pipeline that can go and do this in an automated fashion. You potentially move from hours, or I've seen some products in the past for monolithic application take 6 hours to a day to actually finish building. And now potentially, depending on how your pipeline is set up in concurrency, that process might move down to 30 minutes to an hour. So it's much easier to build and easier to push those changes. Then of course we have tools like Kubernetes. I think Kubernetes kind of won the orchestration war. There's been a lot of tools out there, but now pretty much most of the tools use Kubernetes under the hood because it works really well. It's extremely easy to deploy to. It has a very great API that allows you to be able to do a lot of automation. You can do commands easily, but you can also automate it into the tools out there for CI/CD, and you can also scale out very quickly. It does mean that, as I've talked about, like with my silly mistake, that scaling out can actually happen in a very quick fashion. But on the flip side, if you have a fix, you can also scale out and deploy that fix very quickly. So some of these challenges that were harder in the past. So I have an exaggerated example here for command execution. It could actually be other types of execution. And what we have here is I have a Flask application, which is my SCIM server. And what I've said is, okay, I'm going to get one of the URL parameters and actually use that to run a command. I would hope nobody would do this in real life and actually just call an OS.system with a random command that's provided as a parameter. But this just kind of highlights why you might need protection as the layer 7 for the application. So this is an example, and I'm actually going to run through it live in a moment of actually running it. And what we can see here is the system where I was running it happened to not have a /etc/password, so it got to know such file or directory. But it did mean that that actually executed that command that I passed in the query argument and was actually redirecting any output that would have come to a external site so I could have dumped the contents. So this is kind of an over-the-top example, but I think does highlight why you need to think about the layer 7 security for the application. So some of the things are, as I mentioned before, web applications are still vulnerable, even if potentially the container profile is secured. You might have the Kubernetes set up correctly, you might have your container set up correctly, but you still have a gap in your defense if the actual application that's running and listening and serving up requests is exposed and vulnerable. And we see things, and this is where visibility becomes very important, is having the web application be compromised and then somebody gaining access to that container potentially allows them to do some information gathering as we talk about the east-west traffic, generally within the same data center or the same cluster, where they're able to go and use that permissions that they have to see what's going on within that cluster, maybe hit APIs that now that you're in a container have a different level of permissions than when you're trying to access things externally. We also have, as I already said, if the container is compromised, depending on how you've configured your Kubernetes or other Docker hosts, that could actually mean that that whole cluster or node at the very least is now compromised. So it's a very big aspect of container security, making sure that the actual application is secured itself within the container. So, okay, we've talked about some of those vulnerabilities, but let's also talk about what you can do to actually secure that layer. So there's various layers where you can actually get protection for the specific web applications within your environment. One of the common approaches is at the application layer. So this is having layer 7 protection. So products like Sickle Sciences or Twistlock or Aqua or other things actually be part of the actual containers that you're deploying. And this gives you the ability to be able to set up security policies that are specific to a particular microservice or application at that layer and then scale with it. Another common approach that I've seen with customers is as a separate layer. So this could be similar to like an ingress controller, but usually it's its own security layer. And you might set this up as a reverse proxy service for doing the application firewall and having a request come into that before being forwarded on to the service behind it. And then another common approach is at the consolidated ingress layer. And this is where you have that same kind of security model, especially for things like injection attacks or anomalous types of behavior at the ingress layer. This could be at Envoy or HA Proxy or Nginx are some of the common ingress controllers that we see out there. And also it's interesting to note, and I've seen this with customers that I work with, is as part of that layered approach is you might actually want that protection at multiple layers. So some people might actually put things at the application layer and the ingress layer because this gives you visibility to potential scanning attacks coming in externally to the ingress controller before it ever actually makes it to the application. And that's going to give you your north-south visibility, but then also having it at the application layer potentially also gives you visibility into the east-west to see if there's anomalous behavior, to see if there's attacks that are going on within your actual environment. So that layer or security in layers is an interesting approach because it gives you a lot of kind of different ways to be able to visualize and see the data and protect the actual applications, which is a big part of that overall container security. So what I wanted to do is actually go through a pipeline deployment in an actual real environment. So what I have here, and let me go ahead and minimize that, is I have the environment that I've shown here. I have that code that I'm going to add in. I haven't pushed it at the moment because I want to be able to actually run it. I have some unit tests that are going to get run as part of this Circle CI deployment. I have, as I mentioned, this pretty simple I think, config that goes through, sets up the environment, and actually is going to deploy this out based on these parameters. And so let's go ahead and uncomment this, and we're going to check this in and actually deploy it out. So I'll go ahead and save it. Okay, I'm going to push this out. So I have my Circle CI environment. And once that finishes pushing, I'm going to see a new build process kick off. So I can go ahead and watch it. And this is going to go through and do all of those steps that I've defined in that deployment. So there's a few steps here. It's all completely automated. We're, in this case, still setting up the environment. And then we're going to, in this case, we ran the unit test. Nothing failed, so it didn't stop there. Here, we're actually building and pushing the Docker image. And once this completes, the last step that I have, and this would likely be a development type environment, is actually pushing this to my Kubernetes environment. So this actually pushed both to Docker and to Kubernetes. So we can see here that I have a new deployment kicking off because we have a new version of the image. And that's deploying. So we can see that the new one's deployed. If I take a look at it, I can see that it's the build version 32 and that it was actually deployed to here. So as part of this, and this is talking about the security and layers, is I have my example that I was showing there where I'm actually running this. I've gotten a response back. This is actually a response back for the curl response code, and this is actually executed. So one of the things I want to show is, as part of that kind of security in layers, is we have, this is actually going through a separate security layer, which I have just called reverse proxy. And although I'm able to execute, in this case, a command execution, I'm able to potentially hit a different path and actually have that command execution blocked. So this is kind of important, is what we were talking about, of having those different layers. It's also important to have options. So whether I wanted to have it be part of the web application or have it be a separate layer is really up to what makes sense within your environment. But that visibility is what's important, so that we can see exactly what's happening. I can see a bunch of unauthenticated 401s. I can also see that we've hit a particular endpoint and we have particular things being blocked. So it's also talked about from a visibility perspective. It's not just about what's being attacked. It's also about potentially other types of visibility that's going on, because it's just as important to understand visibility and am I being scanned, or if there are a lot of anomalous behavior that's actually happening, because that gives you an insight into what's going on both externally, the north-south, and then also internally, that kind of east-west type traffic for your security protection for the layer 7 application. I've kind of gone over a lot of different types of things and wanted to really just bring home the point that I found as I've been doing this research, that this is a huge part of that container security strategy. How do I actually protect the web application and that communication to make sure that the compromise of that one component is not compromising my whole kind of cluster. What I wanted to do is also open it up to questions about this, if there's any questions about some of the tools that I used.
All right, great. Now is the time. If you've got a question for Doug, please don't wait. Just use your GoToWebinar control panel and submit your questions. gotten a couple in so far, so we'll go ahead and dive right on into the ones we have. Let's see, the first one, let's see. Okay, so what kind of configurations for layer 7 protection have you seen in customer environments? Brendan, are you with me?
I accidentally had my mute clicked.
Oh, okay.
That's a great question. So one of the common types of approaches that I've seen from a layer 7 is actually having protection deployed at multiple layers. So some of, especially the large organizations I've worked with, I've seen protection installed at the ingress layer and at the microservice layer is a very common approach. And that was done intentionally, even though there's kind of some duplication there, so that visibility into the traffic flows and the detection and scanning, both externally and internally, was made available. Then another approach that I've seen is actually just spinning up kind of a auto-scaling kind of WAF or web application firewall protection as its own service that just gets put in front of new services as they're brought in line behind the ingress controller, so that app owners can just deploy and not have to worry about adding in any security on their own.
Okay, all right. I think I called you Brendan, and I apologize, Doug. Sorry about that. I'm looking at a whole host of names here, and it just got all jumbled up on me. Sorry about that. Okay, next one. How do you scale deployments to a large number of containers?
Yep, that's actually pretty easy. When you're deploying to the actual containers, that's really just updating your YAML files if you're talking about a Kubernetes perspective. And usually there's a few ways of deploying there. You might put your protection in the same application. That does bring up that old kind of debate for Docker, is it a single process or a single service in the container? So if you don't want it in the same container, then updating the YAML file to have the pod have multiple containers, and then usually communicating over TCP or a shared mount are the common ways to deploy out. Or you can also have it as its own layer and then just be able to scale on its own independently. But probably the most common is to just have it be a sidecar to an existing application. Okay,
great. Our next question, let's see, what are the different tools you used in the demo? If you could kind of go over those.
Yep. So I only used a few tools. I don't know if you consider GitHub a tool. I kind of do. It's what I'm using for the version control. I also have a Python Flask app here that's pretty straightforward. It's based off of a template for a SCIM server that Okta provided for doing provisioning. Then I was using Docker Hub to actually push and store my images as opposed to setting up my own registry. As part of the deployment that I was doing, when we look in, actually it's probably easier to look here. I'm actually doing a few tasks in here. So as part of configuring in Circle CI, I'm actually downloading the Docker engine client so that I can do the build and push. And then some of the other stuff that I'm doing is I'm actually downloading the kube control command and then some supporting files for it so that I can actually push my update to Kubernetes. And then of course I'm using Kubernetes, and then in my environment for the layer 7 protection, I was using Signal Sciences for the web application firewall.
All right. Nice. Okay, next question. What are some specific container security measures one can take at the Kubernetes manifest layer?
So at the manifest layer, when we're talking about, I would assume like in the like YAML files and things like that, some of the research I was doing, there's tools like before you deploy Twistlock, Aqua, I think there was another one called like NewView. There's a lot of tools out there that have detection and code scanning before you actually deploy is one way. Some of those tools also will actually scan to make sure is your configuration's correct and following the best security practices. And there's other tools and some of those also that will actually scan the Docker file to see, did you specify a different user? Are you using privileged ports and other types of configurations? So those are some of the kind of common tools out there that I've seen.
All right, great. Lots of great questions so far, but there's still plenty of time. If you have a question for Doug, please don't wait. Just go ahead and use your GoToWebinar control panel, and we'll get to as many as we can. And we have plenty of time, so don't wait. Like I said, go ahead and get it in. Next question, is it possible to leverage your Git repo for learning and testing the lab?
Yes, definitely. So this is actually externally available. It's not a private repo. So you should be able to actually access this one. I'll double check the security settings, but I believe I have it open. If not, I will definitely do so. And I'll add something to the README about the steps that I took to set up this pipeline. But you'll be able to see the config file for the Circle CI, so how I configured this. And I'll leave in the example silly URL for doing the command execution, but it's definitely going to be available for learning and testing on your own.
Excellent. Okay. Next question. Do you prefer Openshift or Kubernetes?
So I played with both. I played with Openshift originally in my Iron.io days when Openshift was still had its own container mechanism. I believe now the latest versions of Openshift have Kubernetes, and actually Red Hat, I guess now IBM Red Hat, has always been pretty good about contributing upstream to the Kubernetes environment, because Openshift is using Kubernetes under the hood. So a lot of the enterprise features that you see showing up in Kubernetes, a lot of it I've seen get created in the Red Hat Openshift first, and then get contributed to the project upstream. So if I'm talking about from a personal just kind of configuration and my needs, then I probably would use Kubernetes. If I need some of the more enterprise user management and role-based access controls, and I would say a little bit more mature front end for managing this type of stuff, then I'd probably prefer OpenShift.
Okay, great. Next question. Let's see. What do you think of AKS?
So the Amazon Kubernetes service, if you're talking about Amazon or Google or Azure, I get all the acronyms confused because they're all pretty similar now, but they're all Kubernetes services. So wherever you do it, it's a lot of it, in my opinion, is about what level of control that you want. So obviously, when you host your own Kubernetes environment, you have full control over the environment, but that also means you're now responsible for scaling the hardware running it. When you start going into the cloud, there's different types of hosted services. So there's hosted services where you have full control of the cluster, and maybe like in Amazon spinning up the EC2 instances, so you can control a lot more of the ingress and the things in front of it. And that gives you control to know how the security is configured for your external to internal, so your north to south traffic. If you need or don't need that level of visibility and control, then definitely the hosted services that just give you namespaces within Kubernetes makes sense, as that abstracts some of kind of the security responsibility and management from your control to the vendor that you're using. So in those cases, you have a sense of reliance and trust on Amazon or Google or Azure, that the way that they're hosting and managing that external load balancing is going to be in a secure fashion that's protecting your actual Kubernetes environment. And I would say, especially like with Google, who created Kubernetes in the first place, they probably have a good idea of actually how to set up that. So there is something to be said for using those services, because they might have a better idea of best practices and configuration.
Okay, turns out he was talking about Azure. So
yeah, I find them the same for Azure, AWS, et cetera. It's going to be the exact same consideration across all of them.
Okay, all right, great. Great. Okay, still plenty of time for questions, guys. So if you have a question, please just use your GoToWebinar control panel and submit it. Next question here, what is the SCIM server? I'm assuming it's the SCIM server. Is it a web application deployed, and is that vulnerable?
Yep, so that's a great question. So it is a web application. So this SCIM server, SCIM is a standard for doing kind of provisioning for third-party tools. Generally, it's going to be around provisioning users and deprovisioning, which is very important from a security perspective. And in this case, it's written in a Python Flask application. So it's a Python Flask web application that's listening on a port. I have it listening on HTTP S, in this case, 5050, but that can be whatever it is you want. But it is a standard actually server. And besides my actual kind of bad coding practice here, it shouldn't be like a intentionally vulnerable application for everything else. It is actually a working application once you remove that particular section.
All right, great. Okay, just got another question here. How much feedback or participation from corporate security groups are you seeing when they convert to DevSecOps or try to secure container applications?
Yeah, so that's an interesting one. From my experience is the container world security is either a lot of that kind of enforcement is coming from the security teams, or for some other organizations I see it actually it's coming from the developer teams. So I see it coming from both sides, and it just depends on which one gets on board with it first. Generally, I'm seeing a lot of participation from the security teams that I've worked with. They're very interested in how they deploy. When I first started doing containers at Iron, there was a lot of resistance to using containers, and it was very slow to get officially approved images deployed out. They had to go through a very formal testing process to create their own internal image that the developers then had to use, as opposed to using some of the publicly available ones. That was back not even too long ago, more like 2014, 2015, and that's now shifted dramatically. Most organizations that I've worked with now, both security and developer teams are much more likely to use existing images out there. They, of course, do verify, but that process is a lot faster than it was before. And there's also a lot more tools now to help them ensure that it is actually a valid image or container to deploy. And those are some of those ones that I mentioned, like Aqua and Twistlock and NewView.
Excellent. All right, that's good to hear. Let's see. Okay, next question. What feedback are you seeing from change management processes, and how have their concerns been handled best when converting from virtual machines to containers?
Yeah, that's another great question, because change management is obviously a big part of the deployment process. So the way that I've seen that kind of shaking out is that obviously in your dev type environments, you go through and things might be completely automated. So the full pipeline that I've configured here. But as part of that pipeline, when you're starting to push to potentially pre-prod or user acceptance testing or to production, they might still have their normal change controls in place, especially for applications that are considered more kind of vulnerable or important to the business. And this is probably more in the large enterprises. Then that might be a weekly change control. Maybe it's a window that they have every week. Maybe there's an exception process that they go through and do, but they don't do a full automation from having the unit tests and everything go through to actually pushing to the Kubernetes environment. So a lot of the tools like Circle CI and some of its competitors out there, as part of those steps, you can potentially add in kind of approval processes. So what you would have there is we'd go through the build, the unit test, and everything would be staged, but then somebody still has to go through, probably have a change control raised, and then go through and approve the final step or steps in order to actually deploy it out into production. You don't necessarily get the full DevOps approach where you're releasing multiple times a day. It does tend to back off a little bit, but it's still not the quarterly, half yearly, yearly release cycle. It's more likely either a daily or weekly, or at the very outside, I've seen some large enterprises move to a monthly release cycle.
Okay. All right then. Let's see. Our next question. Okay. So, okay. Okay, so we're in the process of breaking down the components of a monolithic app. In terms of abstracting away the communications layer, are there tools during development that you recommend?
Yep. So when abstracting kind of, especially the security layer, that's usually where I look at the ingress controllers. It makes it a lot easier when you're not kind of sure exactly how you're going to deconstruct the application to just put the security at a layer in front of it. You can put it at your Envoy, your HA proxy, your Nginx controllers, and that way you have that layer of security while you go through and deconstruct it. Then as you're going through, there are some tools out there that try to help you identify what you can pull out. I'm not as familiar with those, but I do find the actual deconstructing a monolithic application does tend to be a somewhat manual process, because a lot of those functions and the tasks that are doing is just built into everything, and it requires some picking apart and testing and breaking things before you get it back to a working state when you break it out.
Okay. All right, next question. How do you see the process flow you showed us going to change when going from containers to microservices?
Sorry, I didn't hear. Could you repeat one more time?
Yeah, sure, no problem. How do you see the process flow you showed us going to change when going from containers to microservices?
For the containers and microservices kind of approach, the process change is really what you're doing for putting into the container. When people started moving to containers, as kind of mentioned before, they put the whole application into the container and then moved to the microservices. So the biggest change and shift that I've seen is, as opposed to a larger team doing one change control for the whole application, you start to see small pods of teams working on particular functions or tasks and having their own change control and release process for the particular function and task that they're working on, as opposed to that consolidated change control. It might be that multiple DevOps teams work together to have a larger one, but often they can have, if you have 10 pods of developers, they might all have their own release cycle.
Excellent. Okay. All right, guys, we have about, I would say, 10 more minutes. So we've got a couple more questions here, so we should be able to get through them all here. Okay, next one is, how can we test the layer and receive feedback with logs or troubles?
Yep. So I think you're talking about that when you're testing like kind of the layers of maybe security and getting feedback, because there's a few types of things that you're looking for. So when you're actually deploying, obviously you have all of your logs from whatever build process that you're using, so you can get an idea of what's going on. And that's going to be the first kind of layer of security. Do you have good unit tests that are actually testing to see? In this case, I have two very simple ones that are configured, and I'm expecting that if I'm not authenticated, that I'm going to get a 401. I could add in some additional unit tests that I could actually go through and do the authentication and get a level of response back, which if I was being a good developer, I should actually do, but haven't done in this application. And unfortunately, this is a common failing of many developers. Yes, I have a simple ones here when I should have a lot more extensive unit tests. It shouldn't just be two. It should be many more to cover all of the functionality that I'm delivering. That's kind of the first layer. Another layer is there's always, of course, pulling information directly from the actual containers that are running. A common approach that I've seen customers do is they actually, when they're looking at this, they'll send the data, the actual output data, to other tools like Splunk or QRadar or ArcSight, so that they can look at the details there of what's actually happening. In this case, I might have missed the fact that it was trying to cat the host file and then post it somewhere if it wasn't going into another tool. And then presumably the tools that you're using to actually do the security for the web application will give you that visibility where you can go in and very easily be able to kind of get an idea that, oh, hey, look, I've seen over maybe the last 7 days, I have a whole bunch of scanning going on, and then I have a couple specific attacks, also visibility into kind of like what type of traffic is hitting me, and being able to drill in further and see information about what's going on and where it's coming from. So that's going to be looking at the different layers to get that feedback loop. And then the thing that I'm always big on is making sure that your tools are working with each other. So data that comes into this tool should be going into your SIM tool also, because that's going to give you a good component where you can set up your custom dashboards to view information. Also, one of the things I've noticed is your security teams might be in the security products like Signal Sciences, but your developers probably aren't. They might be living in Datadog, they might be living in Splunk, they might be living in these other tools. So you need to make sure that data is available for where they ingest, so that they can just see it right up front and not have to jump into other tools to get that information.
All right, great. Next question then. Have you seen organizations change in the migration from virtual machines to containers? Meaning, have there been some teams that disappeared and others that have grown?
Yeah, I would definitely say that that's true. I wouldn't say that they've necessarily disappeared from the organization, but the structure within their organization changes. So as you start moving towards the container world and DevOps type approach, historically, you've had a lot of people doing development and being part of an overall larger team when you're dealing with VMs, and the developers had to worry a bit more about what operating system that they were running on and be a little bit more part of that process for deploying and configuration for the actual system. Moving to containers kind of changes that paradigm, because now the developers effectively are deciding their own OS and configuration. Usually you're starting with a stripped down OS like Alpine, or maybe stripped down Debian, Ubuntu, Red Hat, whatever. And they're building that environment in the container and just worrying about the container world and their actual code. So whatever they're kind of running locally, they can be pretty confident is what's going to be running in the actual kind of clusters. Also, the teams that were building up virtual machines might move on to other tasks, as instead of having to build up virtual machines, a lot of that is you do move to tools like Azure Kubernetes or Pivotal Kubernetes or Amazon Kubernetes. You're not worrying about the infrastructure, you're just worrying about the code that you're deploying. And this is one of those huge shifts where you're now just focused on your code, and the actual hardware has been abstracted to these third-party companies.
Excellent. I know you're starting to get tired, so I'm just going to ask you one more and then we'll close out the question and answer period. Okay, sorry if I missed this during your presentation, but what are the advantages of monitoring web requests at the app layer versus the ingress layer?
Yep. So I would say there's different perspectives that you get for both, and potentially depending on what you want to find out, it actually makes sense to be at both layers. So the ingress layer is going to give you your consolidated approach. So one of the advantages there is you can set up rules that are going to be more specific or to the consolidated traffic. That's usually where you're going to want to set up things like your rate limiting policies and other kind of controls that are generic across the whole profile. Being at the application layer means that you can now get more of a fine-grained idea of what is actually making it to your web app in those particular containers. along with setting up policies that are going to make more sense for that one application or microservice, as opposed to being shared across multiple applications that might be behind the ingress controller.
All right, great. So we're about 5 minutes to the top of the hour. I'm going to give you a break, Doug, because we've been doing question and answer period for just about 25 minutes now, and we've gone through a lot of questions. So I'm sure you want to take a break now, but I do want to thank everybody who did submit questions. If we didn't get to your question, which I think we got to all of them, but if we didn't, just know that the folks at Signal Sciences will be more than happy to follow up with you offline. They're going to be getting a copy of all of the questions. So never fear, somebody will be getting in contact with you. Also, before we close things out, I did tell you at the top of the hour that we were going to be doing a drawing for 3 $50 Amazon gift cards. So without further ado, I want to go ahead and do that now. Okay, our winners for today's drawing first winner is Gary Johnson. Congratulations, Gary. Our second winner is Stan Tracy. Congratulations, Stan. And our final winner today is Osman Mohammed. Congratulations, Osman. And thank you to everybody who did join us today. Before we close it out again, I do want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. We are going to be sending out an email after today's presentation that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can always find it there. Just go to DevOps.com/webinars, look in the on-demand section, and it will be right there waiting for you. Doug Coburn, thank you so much for your time today. Such a great presentation. Love the expertise. Judging from the quality of questions we got from the audience, I know they got a lot out of it. So thank you very much.
Thank you very much for having me.
Great. And I want to thank the audience also for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.